All right, everybody, welcome back. It's a nice chill in the air today here in Champaign. Hope you guys are enjoying, those of you that are here, enjoying a little bit of fall weather, which I'm pretty excited about. Fall is my favorite season, particularly these sort of cooler temperatures that come along with it. So as always, please feel free to ask questions in the chat or on the forum. I'll be following both, and I'd love to hear from you. This is your session. I'm happy to take requests to sort of go over things that you might want to see, whether that's old homework or bits of today's lesson or bits of previous lessons. This is a flexible opportunity for you to ask questions and get help, and also for us to touch on some of the content that we're reviewing today. So today's lesson is about there's two new big concepts that emerge through today's lesson. One is the way that we work with textual data in Java, using this notion of what's called a string. So we'll get into those. On some level, when we start working with strings, they look a little bit like they're just another type of variable in Java that stores data. We can assign them with literals, we can print them, we can concatenate them using a mathematical operator. But under the hood, and fairly quickly, what we realize is strings are actually something very different than the primitive data types that we've looked at in the past. Strings are actually our first example of a Java object. And so they have some new capabilities and new features, and so there's some new syntax that goes along with them. Java objects are a big topic of this class that we'll get to in a couple of weeks and continue talking about for a while. We actually spend a fair amount of time in this class talking about objects. But at that point, what we'll really be doing is talking about how to design your own objects. And this is actually a really cool thing to be able to do because it opens up Java's type system and allows you as the programmer to use it yourself. So rather than being confined to the types of data that you can store using the built-in types Java comes with, like strings and all the primitive types that we've discussed in the past, you can actually start designing your own types to store and manipulate data in ways that are appropriate to the type of thing that you're building or the type of program that you're writing. But when we start off talking about objects, we're going to be talking about them as a user, not a designer of an object, but as someone who is using a built-in object. And so those are the two focuses of today's lesson. So first of all, let's just talk about text. So Java, text is a really, really important type of data for us to be able to use in our program. And glad to see people liked Public Service Broadcasting. That's a great song, right? That whole album is really good, actually. I have it on vinyl. It's fun. Actually, since somebody pointed this out, and since I enjoy the chance to go off on digressions, that album has, the album itself has two sides. And it's interesting, this sort of, the historical progression of things, because particularly if you grew up in the United States, you remember the moon landing, right? This big feat of American ingenuity. Americans were the first people on the moon. What this album by Public Service Broadcasting reminds you of is that the Soviets were the first to do many things in space. So the first side, the album has two sides. I would go get it and show you, but that seems a little, I shouldn't indulge myself. But the first side, the record inset is red, right? The Russians, right? The Soviets, red, the Red Army. And it chronicles kind of the early days of the Russian space conquest. So Sputnik, Gagarin, the first man in space, the first spacewalk was done by Russian cosmonauts. And I think actually it ends with that really terrible accident that happened early on in the Apollo program. So it took the Americans quite a while to kind of catch up. The flip side is blue, United States, and that sort of starts off with the other side, which is a song about the first time that we put a spacecraft into orbit around the moon, and then kind of goes through kind of the Americans' increasing dominance in space through the moon landing. So it's just an interesting historical trajectory, right? I'd kind of forgotten about how many times the Russians beat us in the early part of the space race. So hold on a sec. The dog is outside and wants to be inside. taken him most of his life to figure out how to bark when he wants to come in, but now he does. So okay, so anyway, text, right? So working with this particular type of information, and again, text is something that sort of distinguishes us as human beings, right? This is something that is a mark of civilization, and computers, the abilities of computers to work with text have improved over the years. Text is in many ways, particularly challenging type of data for computers to work with, because the structure of it is so uncomputer-like, right? Written language has all sorts of ambiguity. It has all sorts of idiosyncrasies in terms of how sentences are structured and what words mean and context. And so, teaching computers to read and interpret what they read has actually been a big challenge, right? If you think about something like Siri, for example, right? You think about that as like a big innovation in computer science, having this sort of digital assistant that I can talk to. A big part of that challenge is not, transcribing the human voice. That's a part of the challenge, right? Is to figure out how do you take sound and create text from it, and that's actually something that is still, a hard problem to solve. But equally important is figuring out, once you have that text, like, what does it mean, right? What is somebody asking? What's the right response? A lot of that has to do with kind of, the first step is transcribe audio to text, so I have text to work with. Now I have text data and figure out, like, what should the text response be? And then, you figure out how to get Siri to say that thing, which is also not particularly hard, right? So Java has a built-in data type for working with strings. It's called a string. Working with text. Normally when I teach this content, I point out the fact that I don't know if strings like a normal way to refer to text. I've been doing this so long that I've sort of forgotten about when I learned about the word string. I guess like literally string has a different meaning, but in computer science, a string is a sequence of characters. So it's a way of representing text. In many ways, strings are sort of on some level. So you might think, well, why do I need this string thing? I already have a way of representing text. I can just store an array of characters, and that's true. And you could store all text data in an array of characters and manipulate it that way. But what you're going to see, and internally, that's how a string stores information. It stores it as an array of characters. But the cool thing about strings, which we're going to see a little bit later, is because they're objects, they come along with all these built-in capabilities that we can use as part of our programs. But when we start off using strings, so if you look at the first couple examples in the lesson, like this looks pretty familiar. So I have an assignment statement. I have a variable called welcome. The type of the variable is this new type that we haven't talked about yet. That's called string. One thing I want you to notice is that the name of that type is capitalized, and that's important. Okay, so I've got something called, this variable called welcome. The type on the left is string, and on the right side here I have an assignment with the assignment operator, and on the right side I have a string literal. So this is the way that you can, if you need a specific string in your program, you enclose it between double quotes. That's important. Single quotes don't work. Single quotes give you a character, not a string. I need double quotes. So I open a string literal with a double quote. I close it with a double quote, and I can print stuff. So this behaves a lot like the other variables that we've seen. Java strings can include, so here's an example, the difference between a string and a character, right? Strings can have multiple characters. They don't have to. You can have an empty string, right? That's a valid string. You can have a string with one character. That's also a valid string, but it's not a character. A character can only store a single character value and only has, and is enclosed in single quotes. So it's important to understand that's kind of a common early mistake people make. If you need to put, so we delimit a string literal using these double quotes. If you need a double quote inside your string, the way that you do this is called escaping. So I precede it with a backslash, and then what you'll see is that it appears in the string as a double quote. It doesn't end the string. If I don't do this, what happens is that Java interprets it as the end of a string, and then I have a syntax error because I've got this stuff hanging out over here that Java can't make sense of, right? But if I escape it with a /, then I guess it's the backslash. Everything works. Now, one of the things that's important to understand, and actually, to be honest, I'm not exactly sure on what types of variables a Java car can actually store. We could experiment with that in a minute if people are curious. But Java strings can store, since more recent versions of Java, Java strings can store arbitrary characters that are part of what's called the Unicode character set. And we can talk about that in a minute if people are curious, because it's sort of an interesting idea. So here's an example. This is Japanese, I think. I used an online translator to do this, so I really have no idea what this means. But you know, so let me, since this is my walkthrough and I get to digress from time to time, let me talk a little bit about Unicode. So remember, if we go back and look at variables and types all the way back to a couple weeks ago, we looked at we looked at the character table, right? And this was an early attempt to represent text data. And you'll see that essentially what this is it's agreed on mapping between numbers to a computer. Everything has to be represented as a number, and characters. So, you know, the character Q in the ASCII character encoding is the number 81. That's a capital Q. When we discussed this, we pointed out the fact that there was a lot of stuff that was missing here, in the sense that, you know, for example, if you look at this, you see pretty much the Latin alphabet. There are some special characters like a tilde and like an underscore, a hyphen, but there's actually a lot of characters here that aren't included. And the reason for this is because the original character values, if you look at this table, you'll see there's only 127 values in it. And the problem was the original characters could only use 1 byte, and that meant that there was a maximum of 256 possible values. So there are character values that you could store in there that are not shown here. But still, even 256 is not anywhere close to enough to store all of the different type of writing symbols that people have used in different languages, right? The Chinese character set is huge. Lots of Asian character sets are really big, and then you have Greek characters and characters that we want to use to represent stuff in other languages. I mean, there's all sorts of different symbols, right, on some level that people have used as part of written text that are not included here. And so the more modern standard that we have is something that's known as Unicode. And the idea behind Unicode is essentially to say, we're going to build a system that allows us to represent everything, right? It's so flexible, and there's so many different, what they call code points, or characters that can be represented in the Unicode character set, that it really can, it's sufficient to essentially represent every possible type of writing symbol that people have come up with. And that includes, it turns out recently, emoji. And so this is a valid string in Java. Now, one thing that I warn you about here is that the in-browser editor, you can see the cursor position is not quite right here. Like I'm deleting the character A and replacing it, but the cursor looks like it's on L. And I think this is because the in-browser editor doesn't really understand that some of these emoji aren't the same width as other characters. Anyway, whatever, we're not going to use emoji regularly in our strings. But you can see that I can use emoji in a string, right? So I can store a string that includes emoji, and I can print it back. And on some level, that's not that different than what we did up here, in the sense that, to Java, these are all numbers internally. And the Unicode is an example of another convention that we've come to, an agreement about how to take a particular type of data, in this case writing symbols, and represent them as numbers. The big difference between Unicode and the systems that preceded it is that Unicode uses more space internally in exchange for being able to represent a lot more symbols, right? So, and that's what allows there to be space for emoji and things like that. Unicode, this is one of my favorite stories about Unicode. I'll just open it up so you guys don't miss it. There's actually part of coming up with Unicode is figuring out like all the different characters that are going to be included and figuring out what are the symbols that we need to include for various types of alphabets. And apparently you know, there were in the case of Japanese, there were a couple. Well, let's see here. So this, can we actually paste this into our thing? We should be able to. Yeah, there we go. Okay, there it is. So that's part of the Unicode character set. Again, I don't speak Japanese, so I have no idea what that means. But apparently, the fun thing about this is that neither do people who speak Japanese. This is a symbol, you know, they refer to them as ghost kanji, that no one is exactly sure why it's there, because, you know, Japanese scholars aren't familiar with this. You know, somebody who is like an expert on the Japanese language looks at this and says, I'm not sure exactly what that is. It's like, you know, if you had a Latin character set and there was just this weird character that's like a shape that no one has ever seen, it's like, they don't teach that in school. It's not part of the ABCs. So anyway, so Unicode has gotten, you know, is so flexible that there are even characters in the character set that may not be actual real characters. And I don't know if this is somebody's idea of a joke or, you know, if this just slipped in by accident. I think the article talks about some possible explanations for this. But anyway, it's sort of fascinating to me that this is the case. And neat, because now, you know, our computers are actually capable of working with and interpreting and dealing with, you know, text even in these non-Latin alphabets. So, all right, so enough of a digression about Unicode, although it's fun stuff. All right, so again, when we start off working with strings, you know, we can concatenate strings together. That's also an important thing we do with strings. So if you have two variables that contain a string or a variable and a literal, you can combine them using the plus operator. There are other programming languages. C++ is one of them. Kotlin is another, where it's possible to take these mathematical operators like plus and minus and what's called overload them, which means give them a different meaning when they're applied to a different type of data. So when I take 2 and 4, so for example, let's check this out. I could say, well, no, I can't. I'll say these are terrible variable names. Okay, so let's try 2 ints, and then we'll see what happens if I add them. You know, and this at this point, this is just normal, you know, algebraic addition that you would expect. So now I'm going to see 6. Okay. Now let's change these to strings, and I'll store the strings 2 and the string 4 as strings. So now these are strings, not ints, right? I've changed the type to the left of my variable declaration, and I've changed the literal to the right of the assignment. And now what you'll see is when I add them, it's actually concatenation, right? The first, all the contents of the first string go first, and then I append all the contents of the second string. And I point this out because it's really useful, and you'll see us doing this a lot now as part of our print statements. So a lot of times when we're printing something, it's helpful to be able to print 2 variables at once, or print a little bit of text in front of the variables so we know what's going on. And this is the way that we do that, right? So you can see a couple examples of this using the variables that are set up in this particular playground. Okay, so far we've just been talking about text data, and that's really exciting, right? Because text is a fun type of data to be able to work with. And over the next week or week and a half, as we continue to deepen our understanding of algorithms and working with different types of data, we're actually going to do quite a few different problems using strings as kind of the data that we work with in our algorithms. But in order to do that, one of the things we have to recognize about strings is that strings have behave differently from the types of data that we've seen in the past. So let me show you an example. And again, this is another place where it's kind of easiest to show first and then tell. Right? Then we try to explain this. So let me give you an example of something that I can do with a string. And the walkthrough goes through, I think, a similar set of things. Okay, so what's going on here, right? I have this part, you know, is sort of familiar to me from the examples I've already seen in this lesson. So I've declared a string variable called example. The type is over here, capital string. That's the data type in Java that I used for working with text. On the right, I have a string literal. I have the 2 double quotes, and I have some characters in between, and then I have the name of the variable. So line 1 is fine. Line 2, I see my familiar call to println, so I kind of understand what that's going to do. I see the name of the variable that I just declared and initialized, but then this is weird. So what's going on over here? And again, whenever we see something unfamiliar in our code, it helps to try to understand what parts of it do look familiar, right? So this over here, right? I see two parentheses. So this looks like it could be a method call, right? It looks, if I separate this, so let's just do this. This looks like a call to a method called length that doesn't take any arguments. If I declared a method, I could declare a void method called length up here, and I could say, it could like print something or whatever. That's sort of what this looks like, right? It looks like a call to a method called length that doesn't take any arguments. But it's attached to this variable called example using this dot, right? This is known as dot notation. So I'm not just calling this method on its own. If I try this, it's going to say that there's no such method. But if I place that method call after the name of the string variable and connect it to with the dot, now the code runs and it prints 14. And 14, interestingly enough, is the number of characters in this string. And if I can convince myself of that by making some changes. So I deleted 2 characters and now I see 12, or I'll add 4 more characters and now I see 16. So it looks like, again, through sort of a process of just squinting and experimenting and hypothesizing and using the name of this method to help us, it looks like what's happening is that this syntax is returning. This is a method call. It's returning an int, it looks like. I mean, I could try, let's try this. Example, let's see if I can put it on the right side of an assignment and see if that also works. Use the name of the variable. Yeah, so that seems to work too. So it looks like it's returning an int, but then somehow, even though I'm not passing any arguments, it's computing the length of the string example. And again, you can convince yourself of that in a variety of different ways by modifying the string and seeing what happens. I could compute the length of the empty string. Okay, great. So this seems interesting, right? We haven't seen this before, right? We haven't seen this idea that I could take a variable and call a method on that variable that looks like it's accessing or using somehow that variable's value, right? So again, I can't do this. So if I change the type of example to an int, now I can't use this dot notation. So what's going on here, right? And the explanation for this is that strings, we talked about the fact that there are 8 primitive types in Java. Int, can I get them all quickly? Long, int, byte, short, double float, char, boolean. That's it. Those are the basic building blocks of all other types of data in Java. And when I said that, I wasn't messing with you. There are only 8. So if we have 8 primitive types, then strings can't be a primitive type. Strings, like we just pointed out internally, strings represent their contents as an array of characters. So strings must be something else. They're not a primitive type. And also, as I pointed out before, there's this interesting thing that we would note, which is that the name of the type is capitalized. That's new. All of the primitive types, int, long, byte, short, all those, their names are lowercase. The thing that's different about strings is that they're our first example of a Java object. And we're going to talk a lot about objects in the future. But what I want you to notice about objects, okay? And we can notice this very, very easily from this little 3-line example. In fact, I can make this shorter by just, having the call to length happen inside the println call, but I'll just leave this. Is that on some level, objects combine some of the things that we've seen about variables and some of the things that we've seen about methods. So objects kind of bring together some of this idea that variables store information, right? And then a method performs a task. And again, we're kind of seeing both of these things with this one example. So here I'm creating the string variable, and when I do that, I assign it some data. So this string, and if I print off the string, you can see it prints hello. And so the string is clearly storing that sequence of characters that I provided when I initialized the string variable. But unlike, so the primitive types were just able to store data. But unlike the primitive types, strings also have these methods attached to them, right? The string object can do things. In this case, I can ask it what its length is. And in the video that accompanies this, and we'll do one of these just in a minute together, there's actually quite a few different methods that are attached to string objects in Java that do different things. I can take a string and split it into parts. I can take a string and find a substring within that string. So give me just a portion of the string that starts at a particular position and ends at a particular position. I think there's a method that will look through a string to see if it contains a particular sequence of characters, right? These are all examples of tasks or algorithms that we can call that operate using the data that's stored in the string. So that's what's sort of cool about Java objects, is that they unite these two concepts that we've been talking about in the past: data and algorithms. I have variables and methods. I have state and state and methods, right? State and functionality, right? An object variable is simultaneously storing information, but also providing us with these useful features or tasks or methods that are attached to that information and operate on it. Okay, so let's do some of these. I'll just grab this playground right here. And I'm sort of reprising some of the material from the lesson at this point. So maybe what I'll do is just if there are questions, please call them out. Again, I sort of feel like I'm duplicating a little bit of what's in the lesson content. So if people have questions about this, let me know. But let's do an example just messing around with strings. So we've seen that I can determine the length of a string by calling this length method. The length method takes no arguments, and it returns an int that equals the number of characters that are in that string. So let's look for some other string methods. So if I look at string Java 14, that's going to bring me into the string documentation for Java 14. So the current, the most recent version of Java is Java 14. That's what we're using for this class. The string object, the string type in Java hasn't changed very much over the years. So even if you looked at some old documentation, it would still be fine. But it's always useful to get used to looking at the most recent documentation. So down here, and again, the video that's part of the lesson goes through this. There are all these different methods that I can call on a string that do different potentially useful things. And so let's try a few. So there's two right here. Let's do one that doesn't take any arguments and then one that does take arguments. So this one is called IsBlank. This table provides a summary. It provides information about the method name and its method signature. So what arguments do I have to pass? And then the return type. And then this is kind of a single sentence summary about what the method does. If I want more information, now there's not that much more information down here, but sometimes there's quite a bit more information down in this longer summary, right? Like for example, for this next one, that has a little bit more, right? So yeah, their anchors don't seem to work properly. So let's go back to, okay, so we're gonna try this IsBlank method in our playground and see what happens here. Okay, so let's try just printing the result of calling example.isBlank, and it says false, right? And what does IsBlank say? It says returns true if the string is empty or contains only white space code points. I don't know exactly what that means, but let's mess around with this. So let's give it an empty string. Now it says true. Okay, cool. But there's also this isEmpty method right below this. So how are the two different, right? So actually, let's just make sure that isEmpty does what we think it should. So this returns true, and now if I put some characters in the string, any characters, it returns false. Let's check isBlank. Okay, so now I'm calling a different method. And again, I'm still using this dot notation. You'll notice that I have the name of the string, and then I have a dot the name of the string variable, and then this thing that looks like a method call. And the reason I'm doing this is that these methods are attached to the string object. You might wonder, like, why is that useful? Well, one of the nice things about it is that anytime you have a string in Java, it doesn't matter where it came from. It could be passed to you as part of a method. It could be a string you created. It doesn't matter where you found it. It has brought along all of these useful things that it can do. And so you don't have to, write this method. You don't have to find it in another place. The string brings it with it. Everywhere it goes, it carries around these methods and these tasks that you can run. So let's try IsBlank. And now we see this is interesting. So IsBlank returns true. Why is that? Well, this string is not empty. This string contains two. I could put more in here. But these are all what's called white space. They're characters that don't print anything. They're invisible, right? They take up space, but the space is white, right, or empty. Let me give you an example of another piece of white space. So this is this character \t is actually a tab character, and it contains a certain number. It represents a certain number of spaces. I could also use a new line. This character advances the output to the next line. Some of this is sort of, I was just thinking about this. Like some of the characters that we use here are actually go back to typewriters, right? So you can think about a typewriter. There's a button that you hit that causes it to. Some of you may not even know what a typewriter is, but my mom used to have one when I was growing up. I mean, she used to, like that was still. We had some of the earliest word processors as well, but there was a day, when I was a kid, thousands of years ago, where people actually wrote up, my mom, who did a lot of work at home, wrote up documents using an actual electronic typewriter. It wasn't a manual typewriter, but it wasn't that different. It was just, was electronic. And so there was a button that you would hit that would cause it to advance to the next line. And we still have that, and I can show you how that works if you include that in the string. So now IsBlank's going to return false, but if I just print the string, what you'll see is that there's actually two lines there. So the string prints first, then it prints this new line character, which causes it to go on to the next line, and then you see second printed on its own line. Okay, so that's an example of one of the string methods. Let's look at another one. Let's take one that has an argument. Okay, how about this? This looks fun. So repeat. I don't know if any of you, when I was a kid growing up, it was always fun to write these stupid programs that would print the same thing over and over on the screen, and you would run those at school, and the teacher wouldn't know how to turn them off, and it was funny because you were, in 7th grade. So this is sort of a variant of that. This returns a string that says returns a string whose value is the concatenation of the string repeated count times. So that sounds like it's potentially useful. Let's go here, and we'll create a string called example. We'll just have it print cool, and then now we'll say example.repeat 8 times. Check it out, pretty cool, very cool. So anyway, this is these are examples of two string methods. This method, as you see by the declaration in the documentation, it accepts a single argument, which is the number of times to repeat the string, and it returns a string. So if I wanted to, I'll call this very cool, and I'll say that is equal to example.repeat 8. And then I'll print very cool. And still print the same thing. And we could do this, 16 times, and it'd be even cooler. So one thing I want, I think it's actually worth pointing this out, this is a great place to do it, is that and I'm not even sure I covered this in the lesson, so this is kind of an important tidbit. These string methods do not modify the string that they are called on. So when I call example.repeat, that doesn't change example. And so let's convince ourselves of that by printing example, right? So the original string stays the same, and what repeat does is it returns a new string. So it's sort of created a new variable that contains the contents of that original string, in this case repeated 16 times. This is actually true for strings in general. there are no string methods that modify the original string. Any string method that returns a new string or returns an array of strings or whatever does not modify the contents of the original string. Sometimes we refer to the contents of the string in Java as what's called immutable. Mutation is the process of modifying something. Immutable means that the data in the string is never modified. So no matter what methods you call on this string variable up here, the contents are always going to be cool. It will return you new strings, right? And there's a bunch of, let's go back to the documentation here. There's a bunch of string methods that return strings, right? Let's see here. So here's one. I'm not exactly sure what that even does. Here's repeat, there's replace, right? So I can replace, I can use this to kind of modify my string, right? So I could say replace, and this takes 2 arguments. I have to give it a character to replace, and then a character to replace it with. And now you'll see what it's done is that it's replaced all the instances of a small o in my string with a big O, and I could use like a 0 sign to make it look super cool. It's like a friendly cool. It's got eyes now. So, but the original string never modified. It's just something good to keep in mind. All right, so there's a few other little tidbits here in the lesson I don't need to go over. Homework problem today is fun, gives you a couple chances to use some new string methods. There are a couple different ways to tackle this, and I would encourage you to check out the documentation to see, this is one of those places where there's a couple of different ways to skin this particular problem, and I'm not going to say cat because I have a cat, but a number of different ways to approach this problem, and depending on which one seems more reasonable to you, you can do it in several different ways. So, all right, so I'm going to pause here. Are methods also written in Java, or are they just some mythical creatures? Oh, the string methods, great question, yeah. So the string methods are written in Java. There's actual Java code that sort of backs each one of these. And in fact, why don't we, since this is fun, why don't we see if we can find it? I'm pretty sure that I've actually found this before. So we're going to look for string.java source. All right, here we go. I don't know how out of date this is. So, it's a great question, right? And I think it's a really important thing to point out. So we're gonna look at this. Now, the caveats here is that there are actually multiple different versions of Java. The original version of Java was developed as a proprietary piece of software by the company Sun Microsystems. That company was later bought, or at least its intellectual property in Java was bought by Oracle, which now maintains it. However, there's also an open source version of Java that's known as the OpenJDK. The OpenJDK tries to maintain compatibility with the official Oracle version of Java, and I think does a very good job. Our playground examples and when the homework problems are all run using the OpenJDK. So we're actually using the open source implementation of Java. However, when we start the machine project later in the semester, you'll be using an official, I think it's the official sort of Sun version of Java that's used by Android. So anyway, the source we're looking at is from the OpenJDK, and the reason is that the Sun source code is not publicly available. Okay, this looks like this is for an older version of Java. This looks like it was for Java 7, which is now actually pretty ancient. Let's see if we can find a newer version. Okay, so this is for Java 8. Okay, so that's nicer. I won't bore you with the details of the history of Java, but Java 8 was a very big set of changes. So the language took a big step forward in Java 8. Since then, even though we're up to Java 14, I would argue that the changes since then have been more minor. So on some level, Java 8, you sometimes think of, and I think Android still is using Java 8 with some extra features that they've bolted onto it. But okay, so all to say, here it is. Let's blow it up really big. Oh, it's too big. Okay, let's check this out. Let's see if we can find some of these. Okay, so here's one of the cool things, right? See this documentation up here, right? The string class represents character strings, all string literals in Java programs. the string class represents character strings, all string literals. So the documentation is actually generated from this source. And again, this is for Java 8. We're looking at the documentation for Java 14, so maybe some things are different here and there. But in general, Java includes this feature called JavaDoc, which we'll talk about more later, that allows you to include documentation alongside your source code. And so that's why this is all here. And a lot of this is, blah, blah, blah. So there's a lot of document. Oh, wait, hold on. This is actually code. Okay, it's just not highlighted. So let's look for one of the methods that we just looked at. Let's look at repeat. Okay, so repeat doesn't look like it was included in this version of Java. I also don't see IsBlank. I do see IsEmpty. Okay, so what you'll notice is that some of the functions that we're using aren't in this piece of source code, and that's because they must be newer. And so one of the ways that we can figure this out is we can actually look over here, and let's look at like IsBlank. So that's one of the ones that we saw that was missing. Okay, so do you see over here, it says since 11. This function was only introduced in Java 11. So Java 8 doesn't have it. The other one that we looked at was repeat. This one also Java 11. Maybe I can actually find a Java 11 source code. Anyway, it doesn't matter. We'll just look at the one that we were looking at. Okay, so here's IsEmpty. This is a very easy method to write. Somebody wrote this. Someone got paid to write this. Maybe someday you'll maintain this code. I don't know. IsEmpty returns the result of this conditional expression, which is true if the value.length is equal to 0. Now, here's what's interesting. Value is, in this case, clearly not a string because I would have to call .length as a method with the parentheses. So let's look at what value is, and we're going to have to scroll up here. Value, it's going to get used all over the place. I wish that this code was easier to read. And this will make more sense to us later when we start talking about our own objects and how to design them. But here it is. So value, remember I said that a string internally stored that information as a sequence of characters? There it is. And again, not all of this is going to make sense to you. Like, what's a class? Why does this say private final? I don't get that. I got you. That's okay, right? It will make sense in a month. But what I want you to zoom in on here is this, right? This is the actual variable that stores the data contained in the string, and it's an array of characters. And there's all sorts of other things, so there's different ways to create strings. Let's look at one of the other methods that we saw. How about replace? I think replace has been around for a while. Okay, here we go. So yeah, and I'm not gonna I'm not gonna walk through this whole method. This one is a little bit more involved, right? This one takes old char and new character. We just use this. Now here's an interesting bit. You guys can certainly understand part of this, right? This says if old car is not equal to new car, right? Well, why do this? Because if old car is equal to new car, then I don't have any work to do, right? The string is going to be the same. So if I replace a character with the same character, I don't get a new string with the same string. So then there's a loop in here, and they're basically kind of figuring out which characters need to get replaced and which characters don't. And then, like I said, they actually return a new string when they're done, not an existing string. So I think I really like the question, because one of the things I think I want to make sure you understand is that none of this is magic, right? None of it is magic. It's just code. Somebody wrote it. And I'm not saying that this is the best code. I don't like some of the variable names they're using here, and I'm not sure, why it's written in this particular way, but somebody wrote this. Like someday there was some programmer, I suspect this was 30 years ago, back when Java was being initially designed, and actually we can go over here and we can look at replace, and we can see when did replace, I just want to figure out like when did this function. Yeah, okay, so this one doesn't say since, right? The other ones said since, and they had a version of Java where that method was added. I suspect this doesn't say since because it's been here since like the original version of Java, right? So somebody wrote this as part of a very, very early Java release. But yeah, someone wrote this. There's a function. every one of these methods here that you see English language descriptions of, there's code. Somebody wrote it, someone understands it, somebody may maintain it. It's probably right. You think about how many millions, hundreds of millions, thousands of millions, billions of times replace has been called over the years by different pieces of Java code. If there was a bug, we'd probably know about it by now. So it's probably right. But I mean, there is no magic here. There's just more code. Great question. Can we change them? Oh, okay. No, you cannot. And there's really good reasons for that. Now, later on, we'll talk about some ways that you can add functionality to Java, right? So if you have a string variable and you want it to have this new feature, right, that you've created, there are ways to do that. Java itself doesn't make that particularly easy, but there are other programming languages that are like Java that actually make this quite nice to do, right? Where it's like if I have an object and I want to add some functionality to it, that's very easy to do, right? So you have your string method that you've created that's really useful in the particular program that you're writing, and you want to include that everywhere the string goes. There's ways to do that. Java doesn't make that particularly easy, but there are some ways. There are some ways around that. But yeah, great question. In general, you wouldn't necessarily want to replace these methods. I mean, these methods, like I said, they're very well tested. They do exactly what we think they do. And so typically, rather than replacing a method, you might write a new method with a new name that does something slightly different, right? That's useful to you as part of your program. You can also see, we saw a couple examples of methods. So here's one called subsequence that didn't come out till Java 4. In the early days of Java, they used a different versioning scheme, and now they've gone to something different. So this is essentially the 4th version of Java, I think. So you also see, the language evolving, right? So there's a repeat method, right? This was added in Java 11, which is actually pretty recent, right? So as recently as, I think Java 11 came out, let's look. Java 11 came out in 2018, actually. So this was only a couple of years ago. Like I said, anyway, I won't go on a digression about Java versions. Maybe I'll do that in the future. But this function was only added recently. And what happens over time is that, the people that maintain the language start to realize that there are certain functions that are really useful to a bunch of people. So it's possible that the people that maintain Java just got sick of people complaining. It's like, why doesn't Java string have a repeat function? This is so simple, and yet I have to write it myself, and that's real pain. And they were like, okay, stop badgering us. We're gonna add repeat, and they added it only a few years ago, right? So that does happen over time, right? And if you look through these different string functions, you can see, a lot of these go back a long way. Other ones, this one, right? And this is actually part of a new feature of Java, right? So this has only been out since Java 13. This one came out a long time ago in Java 1.5. But not every one of these methods has always been part of Java. The language does evolve. Great question. All right, so I think that is probably enough for one day. Thanks for some excellent questions. I hope everybody's doing okay. Good luck with today's homework problem. Keep in mind that it is due at midnight Central Time. And I will see you all again tomorrow.